All right, now we'll look at applications, marginal analysis. The term marginal, the easiest way to think about it, it's the business word for derivative. Okay, so we've already talked about some basic derivatives, like with the power rule and things. Those basically meant instantaneous rate of change, or slope of the tangent line, if you want to call it that. We use those same applications on profit, revenue, and cost in business. Okay? And when you do a derivative of those functions, it's called a marginal function. So here are the three marginal business functions that we'll look at. So remember, c of x was the cost function, so c prime of x represents the marginal cost function. Likewise, r of x was the revenue function, so r prime of x is the marginal revenue function. And then p of x was the profit function, so p prime of x is the marginal profit function. So it's the derivative of cost, the derivative of revenue, and the derivative of profit is what we're looking at. Note that there's no such thing as a marginal demand or price function. You as the business set the price. Wouldn't make any sense to do an instantaneous rate of change of a price you set. Okay, so there is no marginal price function. This is just redefining marginal cost, marginal revenue, and marginal profit in a little bit different terms. So notice it says, is the rate of change. Remember, derivative meant instantaneous rate of change. So this is what we're talking about here. So when we say c prime of x is the rate of change of the total cost per unit change and quantity x, what we're saying is, if I plug a value for x into a marginal cost function, it doesn't give me the total cost. It gives me the change in the cost. Same thing can be said for marginal revenue and marginal profit. It's not the total revenue, it's the change in the revenue. It's not the total profit, it's the change in the profit. All right. You'll notice on several of these questions that they ask in this section are kind of a repeat of what you did in functions and models. But we'll still look at them again, and then they kind of expand onto it at the end with the derivatives. Okay, so question 1 there. A vendor charges $15 for a jacket. What's the demand function? So remember, that's the same thing as saying price, mathematically anyway. So the price function is going to be just 15. Okay. On Hawks, you just type the number in. You don't have to type the P of X. Question 2 looks similar to question 1, but look at what it's asking. Vendor charges $39 for a shirt. What's the revenue function? Okay, so remember, revenue was X times price. So in our case, X times the price is $39. It's going to be 39X. Again, on Hawks, you just type the 39X part. Okay, question 3. Literally, it's the same question as question 2. It's just that the price they give is not an actual dollar amount, it's a function. You'll have functional prices, most commonly used when you're selling a high volume of an item. You typically cut the purchaser a break, okay, and not necessarily always, but in a lot of things. I always use the example, take a little bitty local hometown grocery store that's got just one store, and they're selling, say, dog food. Well, they might buy I don't know, 50 bags of dog food to sell from a supplier. Compare that to like Walmart or Kroger, or one of the big national chains that have big warehouses all over the place. Well, they're not going to buy 50 bags. They're going to buy 5,000 bags or even more than that. So when somebody is going to buy more units, you typically give them a little bit better price. Okay, so that's where a functional price function would come in. All right, but anyway, it's still the same thing. Revenue is still going to be X times price, so all you've really got to do here is multiply that function by X. Okay. Go ahead and multiply that out. So we'd have 39.9x minus 2.4 x squared. Alright, let's scroll down here. Number 4, peanut vendor has an initial startup cost of $5,800 and an item charge of 80 cents per bag of peanuts. What's the cost function? In the last section, I showed you a generic formula to get a cost function. And that generic formula was your cost function is going to be any fixed cost plus your unit cost times X. Okay. So the fixed cost here, the startup cost is your fixed cost. That's money they had to pay out so they could get started. Okay, so startup costs, same thing as a fixed cost. $5,800 plus a unit cost of 80 cents a bag times how many they sell. So there we go, 5,800 plus 0.80x. Alright, number 5 is same thing. They're just kind of using different terminology again. Supplier of souvenir hats charges street vendors for each order based on a setup fee of $41. Okay, setup fee, that's going to be a fixed cost. And an item charge, or a unit cost, is another way to say that, of $3.40 a hat. What's the cost function to the vendor? So you're going to have your fixed cost, $41, plus your unit cost, $3.40 times how many you sell. Okay, there it is. Same thing as number 4. Alright, so again, at least the first half of the questions on the homework are kind of the same stuff you already did in the previous section. Okay, you finally get it to some derivatives down here. Say number 6. The total cost of producing X novels is given by the function c of x equal 500 plus 17x minus 0.7x squared plus 0.1x cubed. Find the marginal cost function. So there's that term, marginal. That's just the business word for derivative. They want to know the rate of change of the cost. So you're just using the power rule that we've learned previously and taking the derivative of this function. So I don't want c of x, I want c prime of x. Derivative of 500 would be 0, so that's gone. Derivative of 17x would be 17. Derivative of negative 0.7x squared would be negative 1.4x to the first. And the derivative of 0.1x cubed would be 0.3x squared. Okay, so all they're really asking for is what's the derivative. Alright, I'm going through these rather quickly, but one more question on here. You'll see this question multiple times on the homework. Sometimes it just asks for a function. Sometimes, like this one, it'll ask you to plug in a number at the end. So they're giving us a number to plug in. But it's going to be the same process either way. It's just on this one, you've got to plug in a number at the end. This kind of encompasses everything we've talked about in the last section and this section. Okay, so let's read through it. A sales representative for a company that produces toasters can sell X units of their deluxe model if the price is 71.7 minus 0.02 X dollars. The total cost for these toasters is given by 0.06 X squared plus 4.6 X plus $6,100. Determine the marginal profit for 129 toasters. Okay, so let's think about what we need. Forget about the 129 for right now. We want to get to marginal profit. We need marginal profit function before we can plug 129 into it. Well, before you can get to the marginal profit, you're going to need the profit. Okay. And how do we get profit? Well, profit was revenue minus cost. Okay, well, let's look at what we have. They gave us a cost function right here. So we've got that part. What we don't have is the revenue function. But we do have the price function. So remember, R of X is X times price. So we'll be able to find that revenue function, then plug it in here, and then we'll be able to get the profit function. Once we get the profit function, it simply is take the derivative to get to marginal profit. Okay, so let me start with a clean page here. Let's start off with getting the revenue function. Revenue is going to be X times price. So again, in our case, that's X times 71.7 minus 0.02 X dollars. And go ahead and multiply out there. That's 71.7 X minus 0.02 X squared. So there's our revenue function. We want to get to profit. So now that we have revenue, they gave us cost in the question, we can use profit equal revenue minus cost. Okay, so profit is 71.7x minus 0.02x squared minus our cost function given up here, 0.06x squared plus 4.6x plus $6,100. Let's go ahead and combine like terms. So negative 0.02x squared minus 0.06x squared is negative 0.08x squared. 71.7x minus 4.6x is going to be 67.1x. And then distribute your negative sign. This is minus 60, should be just $6,100. For whatever reason I wrote 61,100 here, so 6,100. Okay, so there's your profit function. We need again marginal, so that's the derivative. So the derivative of negative 0.08x squared is negative 0.16x. Derivative of 67.1x is 67.1, and the derivative of negative 6,100 would be 0. And lastly, they're asking us for the 129th item. So we plug in 129 for x. going to be $46.46 is what I have here. Okay, so let's keep in mind what this means. It's not saying that the profit is $46.46. What it's saying is if I sold the next item, okay, so we're at 129. So if I sold the 130th item, I would make an additional $46.46 in profit. It's the change in the profit per unit. Okay? So not the overall profit, but the change in the profit. All right, and that's it.